Hello there. We're going to do a little bit of number theory. You may be very familiar with even and odd numbers. Today we're going to look at the lesser-known treven and trodd numbers. So we need a couple definitions first. A treven number is going to be defined as 3 times any integer. So a treven is a triple. It's 3 times an integer, 3 times n. N's an element of the natural numbers there. So examples of treven numbers would be like 0, 3, 6, 9. You would hit the negatives, -3, -6, etc. A trodd number is going to be a treven number plus 1. So this would hit numbers like 1, 4, 7, etc. Now a negtrodd, a formal definition of a negtrodd is actually the negative of a trodd, the additive inverse of a trodd. But through a little bit so this will hit numbers like -1, -4, etc. And through a little bit of trickery, you can actually show that this is equivalent to 3n plus 2. Or you would use a different letter there, 3m plus 2, or again, n is an element of the integers. I'm not going to do that one right now. That could be left to the reader. We're going to do a couple properties here. So we all know that like an even times an even is an even, an odd times an odd is an odd. But when we start looking at treven and trodds, what are we going to get? So let's start with a treven times a treven. I'm doing this for any 2 treven numbers, and I need to use different letters for them. So I'm going to have 3n over here and 3m over here. I could use whatever letters I like, but they have to be different. If it's both 3n and 3n, then you would just be squaring a treven number, but I want any treven number, so that maybe this over here is 3, and this over here is 33. Or maybe I have 6 and 312. Okay, so what do we get? Multiply those together, I get 9nm, and now I'm going to factor out a 3. So, outside I have a 3. This whole thing here, 3 times n times m, that is going to be some kind of integer, if anything. I could call it p, so then I have it in the form of 3 times p, and that is in the form up here. So this is going to be a treven number. So I'll put that up here. This is treven. Okay, on over here. I'm going to do a trodd times a trodd. First trodd, I'm going to stick with n for now. I'm going to have 3n, and then I'm going to multiply this by another trodd. It needs to be a different trodd, so it's going to have, or it could be the same, but it's going to have m instead of n. Otherwise, again, I'd be squaring it. Now remember to put these in parentheses so that I'm doing this whole number here, this trodd times this whole number here, which is also trodd. And tell us what m and n are. So m and n, in this case, are both elements of the integers, denoted over here. Otherwise, if they're not integers, then you wind up with stuff like 3 times 0.5 plus 1, so you have a number of like 2.5, and that is not a whole number, so not trodd. Okay, so multiplying through. Alright, this one gets a little bit tricky. When I multiply these two together, I get 9nm. And then I do the outside, 3n. Then I do the inside, 3m. These are different from each other. This one is with n, and this one's with n, and this one is with m. And then the last I get 1. Now, I need to show that this is of some kind of format, so I want to see, well, is there anything I can factor out of a group of these? 9, 3, and 3, yes, I can factor out a 3. So I do that, and the leftovers, 3nm. Factor out of 3 here, I get n. Factor out of 3 here, I get m. And then the leftover, there, a little plus 1. All of this here, this is just, well, n and m are integers, so multiply, add. This is still an integer, and I have 3 times some integer plus 1, and that is in the form of a trodd number. I'll write it as a little 3 plus p there, but trodd times trodd is trodd. Okay, last one, negtrodd times negtrodd. I don't want to take any guesses here. So far we got treven times treven is treven, trodd times trodd is trodd, negtrodd times nedtrodd. Let's do it. So I'm going to use the version that's 3n plus 2 instead of the negative version. If you're really interested, you could prove that this up here is equal to this. That's a nice little exercise. Okay, so again with n and m, tell me what they are. They're elements of the integers. And then start your distribution. So first one, 9nm plus, now I'm going to do 3n times 2, that's 6n, plus the next one, 2 times 3m, that's 6m, plus 2 times 2, that's 4. So already this one's looking a bit different. Okay, so how are we going to do this? I'm actually going to split that 4 up. So this is a nice little trick that you can do. This 4, this is going to be written as 3 plus 1. And now I'm going to look through and factor. And what can I factor out? Well, 9, 6, 6, and 3. I can factor out a 3 from all of those. So making sure that I did this right, that's going to multiply to 9nm. That times that will be 6n. That times that will be 6m. This times that will be the 3. And then I got that plus 1 over there. And all of this here, all that mess, that's just an integer. So ultimately, this has the form of 3 times some integer plus 1, which is trodd. So this was a little bit unexpected here, that negtrod times negtrod wasn't negtrod. Negtrod times negtrod wound up being a trodd number. And we could have also tested that by doing things like 5 times 5 is 10, and 10 is 3 times 3 plus 1. So just experimenting, we would see that that is a trodd number. But that doesn't cover it for all cases. That's just a little bit of inductive reasoning. And what we're doing here, all of this stuff, this is deductive reasoning. Thanks for watching. Character and Scholarship for Life.